Let's say we have a healthcare study where we observe about 130 patients. They are diagnosed as having a common cold or flu. And we note down their symptoms. How many of them are sneezing? And how many of them are not sneezing? So we see that about 20 who have cold are sneezing, and about 30 who have cold are not sneezing. In the flu case, we have the distribution like this, 50-30. So how many total observations we have? We observed 130 people, out of which 70 are sneezing and 60 not sneezing. 50 have cold, are diagnosed to have cold, and 80 are diagnosed to have flu. Now, these numbers are very important, and they can help us predict about a case in two different ways. So a patient comes, we don't know the symptoms. What can we say about the diagnosis? Without looking at the symptoms, we will just look at our prior knowledge about cold and flu distribution. And we will say the probability of having cold is, let's say, 50 divided by 130. So we can write it here. A random person who comes in, we want to estimate, does he have common cold or flu? For flu, it will be 80 by 130. Similarly, if we have a question asked that how many, if a person comes in and we don't know if the person has flu or cold, what is the probability that the person is sneezing? We will say probability that the person is sneezing is 70 by 130. And probability that the person is not sneezing is 60 by 130, right? So these numbers that are on the margins are referred to as marginal probabilities. And they help us answer basic questions without knowing the other condition. Like if we don't know if the person has flu or cold, but we want to know what's the probability the person is sneezing, we will just look at this marginal probability. And if we don't know if the person is sneezing or not sneezing, we want to know if a random person has cold or flu, we will look at this marginal probability. How about the information in these cells? So in this cell, we can answer questions, how many of the people have cold and they are sneezing? That means probability of a random person having cold and the person is sneezing as well. It is 20 by 130. And so on. Probability that the person has flu and the person is sneezing is 50 by 130. Now, the person in this question is someone that we don't have in these counts. We observed 130 patients, their symptoms and their diagnosis. And based on that, we have this contingency table. That can help us answer many interesting questions. We looked at two interesting questions. Marginal probabilities help us answer if a random person has certain condition or certain diagnosis. For condition, we will look at these numbers. For diagnosis, we will look at these numbers. And they refer to as marginal probabilities. If we know both the condition, we want to know both the condition and diagnosis for a random person, we will look at these values that are in each cell of this table. 20 by 130 will be the probability of a person who just came to the hospital having cold and the person is sneezing as well. We refer to this as joint probability of observing an outcome based on two variables, cold and sneeze. Now, the interesting thing starts now. The joint probability is a combination of two things, the marginal probability and conditional probability. What is conditional probability? Conditional probability is when we want to answer a question based on a given information. So we are going to do that now. Let's say we